Now, if we want to find the equation for our trend line, or to see what the correlation is for our scatter plot, all we do is we click Get Summary, and there you can see that we have a linear trend, which is engine size is equal to 0.0032766 times the weight plus -1.9. So that gives us the equation for our line of best fit, and it tells us that our correlation value is 0.8451, which is quite a strong correlation. There's also the number of our sample size. So that's how we would get those correlation and regression pieces of information. Now, just a few extra tips. First up, we don't necessarily need to swipe this over to see our variables. We can also just hit on View Variables and it presents them as a list down there. Secondly, if we are talking in terms of explanatory and dependent variables, we would normally want the explanatory variable down the bottom and the dependent variable on the size. Now, with this data here, I would probably say that the engine size would be the explanatory variable and the resulting weight of the car would be the dependent variable. So we want those two variables on different axes. Now, in order to do that, we would just switch the places just here with those variables. So engine size would move to variable 2 and weight we would move up to variable 1. And when I move weight down here, because it's weight to weight, we would expect a straight line. And engine size, and now we have what I would call the explanatory variable in the correct place and the dependent variable up there. And then going through fitting a line of best fit again, just for practice, add trend curves, linear, show changes, done, and get summary. And what you'd notice there is that our linear trend has now changed. Sorry, our trend line equation has now changed, but the correlation is still the same. So it doesn't matter which axes we plot our variables on, the correlation will remain the same even though our line of best fit equation will change.